My name is Alan Rudolph. I'm the Vice President for Research at Colorado State University. I'm delighted to moderate this panel on the digitization of energy. I can't think of a topic more foundational to the discussions we've been having over the last day and a half, and quite frankly, discussions that are going on almost in every sector. Health, you can pick one: healthcare, environment, energy. We are awash in data, we're digitizing it, and in the energy sector, it presents some real interesting opportunities, and we've got a great panel to talk about those. I mean, we're going to be talking about the digitization of energy and how it potentially transforms its use. From a design perspective, I mean, we're now designing a lot of architectures to handle the digitization of energy, how we actually implement this architecture. All of the controllable devices, we've heard about Internet of Things, but all of the controllable devices, even within the energy sector, their integration onto a grid that comprises multiple energy sources. And then, of course, the implications of that, the analytics. I mean, it's great that we have a panel diverse with an academic and a national lab, a vendor, a utility system, because we're all looking at analytics from a different perspective. That's, I think, still very much a research question as we look at machine learning, deep learning, the tools we have available to us. It's a question of actually workforce training. We'll touch upon that as well from the perspective of how are we going to train up a workforce to be able to handle the digitization challenges and opportunities that we face. And then I think on all of our minds, and we'll talk probably a little bit about the security aspects of the digitization of energy. I think as we've seen in the last few years, this particular element of the digitization of energy has risen in our awareness, and I think in the potential to address what is really going to be the future of not only how we build it, but how do we protect it and how do we secure it, not only for national security implications, but for implications for resiliency of the grid in terms of its operation and performance. The last thing I'll say is that, you know, the universities in the Colorado region have all expanded their computer science departments, or in the process of expanding their computer science departments. I think you're going to hear new efforts of investments. I reflected one in academia. I think from all our panelists, you're probably going to be hearing about newer efforts, not only to look at the digitization, but to implement architectures to deal with some of the issues that I just talked about. So it's really clearly an area on the rise as we digitize more and more of our information, most of the data needed for these systems and grids. So with no further ado, we've got three great panelists: Juan Torres from NREL, Antonio Trujillo, a technical manager from Eaton Corporation, and Clifton Black from Southern Company Services. We're going to start out with Juan Torres. Juan.
Great, thank you. So I'm going to talk a little bit from more the cybersecurity and the resilience perspective, and I look at it as an opportunity, not necessarily just exposing new vulnerabilities, but where can we take advantage of the fact that we're bringing in some new technologies with the perspective of security resilience from the very beginning, as opposed to, I believe when, you know, our energy infrastructure has evolved over time, that necessarily was not really at the top of the list. It's something that we've typically bolted on later. You know, initial focus when we're talking about energy is usually about reliability, about affordability, about getting energy delivered when we need it, where we need it. So security, it tends to be an afterthought. So is there an opportunity for us then to start to build some of these concepts as we transition into a more highly digitized energy economy? Let's start with resilience. And there are a lot of definitions out there with regards to resilience, but here's one, and it's based on National Infrastructure Advisory Council report. It really is framed around an event, something that may disrupt energy infrastructure, and what you do in preparation to prepare so that you can minimize the impact and that you can minimize the downtime, the cost, and so on. And then what do you do during the event, when the event actually occurs? You know, how do you isolate? How do you protect so that you can get the system back up and running as soon as possible. So then there's also this after event element of it. And there are ways to do this through technology, there are ways to do this through procedures, through policies, and so on. And you really need to have all of these well aligned to maximize the impact of the resilience capability here. Let's focus on one element of the grid here where we're seeing the biggest change, and I should say where the power grid more specifically, and in general, where energy all comes together, is at the consumer. This tends to be where things are changing most rapidly and where policies, especially on the grid side, are maybe more vague, where traditionally the focus on grid reliability and power grid resiliency and so on has been at what's called the bulk power grid, which essentially is at the substation back to the centralized generation plants. But where things are really changing are down near the consumer. And this shows, one example, a home. It could be a business, it can be an industrial complex, it can be a hospital, you name it. But there are all these devices that are coming into play that are changing how we use energy, because the consumer now is much more proactive and much more engaged. They're also much more knowledgeable about energy, how they use it, what is the cost, how they may want to maybe vary when they're using different resources. And we're getting to the point where these systems are much smarter than we are. So our home energy management system will make a decision based on time of day. We may set our thermostat, or even if somebody's in the home, you may have sensors that will detect what lights come on and things of that nature. So this is where things are changing significantly, probably where standards are the loosest, but where we also have an opportunity, though, to improve these, the direction, the trajectory of how the consumer will engage, even to the point where we'll have buildings that can help improve overall grid reliability. But let's not forget about the fact that to do this, we are bringing in digital technology, which tends to bring in potential vulnerabilities, and there's always somebody out there looking to take advantage of the fact that we have these systems where what we're seeing over time is that the weakest, the softest element of any cyber-based system is the human in the loop. It's not always the technology itself, it's the fact that we as humans are not using it appropriately, we're not setting passwords, we're not aware, it's not within our culture necessarily to recognize these things. We just make assumptions and assume the technology is secure, assume that it's architected appropriately, and so on. So there are a lot of things here where we as people can make a difference. The chart on the left here, this comes out of the Worldwide Threat Assessment from the Director of National Intelligence. It's available on the web, so you can see where our government says the threat is. And with regards to cyber, this is from last year, and it's pretty current. If you look over time, from 2007 to 2017, these are the number of countries that have cyber attack capabilities and how it's increased over that 10-year period from around 3 countries to about 33 countries. And not all of these countries necessarily like the US. And we have some of our technologies being developed in those countries as well. So we have to be very cognizant of what we may be purchasing from vendors that may be located outside the US. On the right-hand side just shows that in green here, energy infrastructure is a target, big target. These are successful attacks that were documented on our infrastructure, very similar to communications and critical manufacturing as far as how big a target it's been. But let's not forget the fact that the biggest cause of disruption in our energy infrastructure is still storms. And how can we take advantage of this technology to improve our sensing, to improve maybe isolation, communication, and so on? And we've got an opportunity here, greenfield opportunity in Puerto Rico, where we're exploring. You can build in smart microgrids that are islandable, that can section things off. So there's a huge opportunity. Unfortunately, it's tied to a major catastrophe and disaster. But you can see here, one of the things I'll highlight, the size of these circles, and you may not be able to see all the detail, depict some sort of a relative cost to other storms. And right in the middle is Katrina, is the big orange circle. You'll see Sandy just to the right of it, and several other storms. And then this was 2017, so Maria had just hit, so it wasn't included in this data, so I included on the right. The cost $90 billion, Harvey as well, 125. So it appears over time here, the impact, the cost of these storms is just increasing. So I'll leave you with this. Bottom line is, I believe we need to take more of a systems approach as we incorporate digital technology, and not look at it strictly from a cyber perspective, but also the fact that these systems are operating in the context of multiple threats. And how can we take advantage of these technologies that give us better awareness, understanding of the system, move toward things that may include some more automation in the system and less human in the loop, because the system, we as humans just won't be able to respond fast enough. So incorporate a systems approach where we look at threats from cyber, threats from physical attacks, which are not going away easy as well, and also storms, natural disaster, natural types of events. Look at it from that context, and how can we design a more inherently resilient and secure system in the future.
Great, thanks, Juan. So Antonio, moving on to the industry sector, I know Eaton has done a recent partnership with NREL and is in Colorado now, and love to hear your perspective on this topic from the corporation.
Absolutely. Is it working?
It's up there, and it's, yeah.
Oh, there you go.
There you go.
All right. Well, thanks for inviting me. So we are very happy to have a presence in Colorado. It's been a year now when we moved 22 of our scientists, and now they are co-located with NREL in the ESIF facility. And the experience has been a blast. I mean, we are extremely happy. We signed a contract for 3 years. We want to keep it for more than that, so hopefully in the future we can see that. So I just want to give a quick kind of background of what Eaton is. And anyone here have heard about Eaton and what Eaton does? Yeah, so it's interesting. We are a Fortune 500 company, but we're probably the most known Fortune 500 company. And hopefully this helps a little bit to spread the word of what we do and who we are. So we are a global company with a presence in more than 90 countries. We have 95,000 employees. We have two sectors, electrical sector and industrial sector. So we do businesses, we build products and provide services for utilities, for data centers, oil and gas, residential, commercial, and industrial electrical installations. Primarily, I will say, in the distribution side, we do a little bit on generation and transmission, but very heavily on distribution. And over the industrial sector, we do businesses for aerospace, hydraulics, and vehicle. So many times people ask me, well, what is what Eaton does? And I can tell you, we do a lot of things, lots of different things, and that gives us a really unique position where we can use different technologies, and we can use platforms that can be applied across different applications. So that's a big strength for us. So in the utility sector, for instance, we do transformers, distribution transformers, medium voltage regulators, switchgears, capacitors. For the data centers, we are a major provider of UPSs, three-phase and single-phase UPSs. We do circuit breakers. In your home, it is likely that you have one of our circuit breakers. In the case of the industrial sector, for instance, we are a major player on internal combustion valves for internal combustion engines. So 70% of the valves that are in the world actually are manufactured by Eaton. So it is likely that your car, if it's not an electric car, will have one of our valves. We do fuel pumps for aircrafts, for instance, the A380, for instance, the Boeing 787 has more than double the content of the previous aircraft from Eaton. So we are very proud to be part of that industry too. We have hydraulic traction gears for big tractors and a lot of equipment also for heavy equipment, hydraulic pumps and bulbs. So what I would like to spend most of the time really is in our strategy, and this is all public information, our strategy to what we call the digital power management, which is not only thing that digital energy. And we have really seen six we call forces that are really changing the nature and the way we look at power management. We're a power management company, so it is extremely important for us on these type of strategies. And if you think we have all these macro trends, so these significant forces are, let's say, one level down, one level deep in terms of also opportunities. So the first one that we can see is industry convergence. And in here we see the need of Internet of Things. We see companies more interested in looking into the factory of the future, Industry 4.0, and we are a big supplier in that area. We are actually gearing our own factories to be able to manage power, to be able to connect all our devices, drives, for instance, lighting, high-back controls, and be able to operate our own factories at much higher efficiency. So one example, we gear up our facility in Puerto Rico, in Arecibo, and we are saving close to $1 million per year. The investment was paid probably in 4 months. So big opportunity there. End-to-end solutions, so we provide not only the design and project management and even installation, but also we can work with our partners, customers, to even define potential new business models. So we look into an end-to-end solutions. In terms of solid electronics, we see a big trend. We have a $2 billion business where we use solid electronics, power electronics devices today, UPSs, medium voltage drives, low voltage drives, energy storage drives, traction drives, and they're all use these power transistors. And we're looking into the new next generation of power transistors based not only on silicon, which we have been using for over 40 years now, but actually we're looking into silicon carbide, wide bandgap devices that are much more efficient. In terms of advanced materials and manufacturing, we have a center of materials that are developing nano composite materials, that we are also developing thermally conductive polymers and 3D printing, additive manufacturing. And we're using additive manufacturing not only to do prototyping or rapid prototyping, we actually have production parts made with 3D printing today, made of metals or some polymers that we provide today to aerospace industry. So this is another way of not only digitizing the energy, but also digitizing our own internal processes. And then flexible energy management. We all know that we have a very old infrastructure, and we have a big and unique opportunity to change our infrastructure in the next coming years with more renewables. And with the electrical vehicles will be probably around 38% of the load by 2030. So a significant change are coming, and this is for us a big opportunity to make things different. And this is actually our group that is co-located with NREL is the one looking into these areas and these opportunities, looking into what will be the next generation of power systems, the power systems of the future. And then our open innovation strategy, it is very clear for us that we need to make sure that we have the speed and the scale that is required by our customers to bring differentiated products to the markets. And for that, we need to have a strong strategic partnership. So in order to implement these, we are looking basically at 4 verticals that will support our digital solutions. So we are, and we have been doing things for more than 175 years. So these are the assets, and we're looking into add more sensors and ways to measure what is going on with these assets. So we're adding this level of intelligence. And by having these assets with this level of sensing and awareness of what is going on, we now need also the connectivity, so the Internet of Things. So we do the things, but we need also the Internet of Things. And we are looking into use, standard, industry standard protocols, open protocols. We are not closed by any means, so our controls can be connected to our Eaton products, but we can also connect with our competitors. And our products are also open to be able to connect with our competitors' controllers. So we are definitely open in that sense. And very importantly, the intelligence. So what we're going to do with all this information, it is extremely important to understand what we can do. And for that, we have a center of intelligence. We're looking at into what we call the Intelligent Power Center. We're looking into understanding the aspects coming from our devices. We call these the electrical power genome or mechanical power genome. So we, like a human genome, we can see, the components of a human in terms of color of eyes or maybe color of hair or prompt to certain illnesses. We can look into frequency, we can look into voltage, we can look into transients, current, and identify patterns of what is going on in our devices. So we can detect potentially, let's say, a pump that is having some kind of cavitation problems by just looking into these traces. And we can provide the state of health, we can provide prognostics and diagnostics, and increase efficiency and reduce downtime issues in processes. And then we're also looking at new business models. So digitization of energy is not only what we just described, but it's also a big opportunity to make different businesses and add additional stream of revenue to our products by providing additional value and additional information to the customer ecosystem. So this is a big portion for us. And then I just want to leave with the message that it is impossible for Eaton, it is impossible for any manufacturer, I think, to do this by themselves. Having a very strong world-class partnership is extremely important, and we have that partnership in place. From the very fundamental development of technology, the very low TRL levels, all the way to commercialization, to application-specific or even demonstration and validation. And I would like to point the collaboration that we have with NREL that we established a year ago. 22 scientists were a budget of around $9 million every year that we are executing from NREL, and we're extremely happy to use the ESIF facilities in order to validate some of our technologies. So thank you very much.
Thanks, Antonio. All right, Clifton, you're going to give us a perspective of the utilities, note your research and development in the utilities Southern Company Services. So please.
Absolutely, thank you. So it's really great to be here, and I appreciate the opportunity to speak from the utility vantage point and then also kind of outside of the Denver area. The fact that I'm from Birmingham, Alabama, I thought I would begin with a little bit of introduction to Southern Company. Southern Company, our traditional electric business is in the southeast United States, so Alabama Power, Georgia Power, Mississippi Power, and the others. We also have a wholesale energy company, Southern Power, where we've got generating capabilities across the U.S. We also have a few other affiliates that have a variety of turnkey solutions and other capabilities. And so we actually are stood up from a capability standpoint in all 50 states. We've got 9 million customers, and that's between gas and retail. And so that's one element. We're no longer just electric. We have gas, and we're almost 50-50 between our gas and electric customers. 44,000 megawatt of generating capability. So talking about digitization, if you look on the left, our traditional central station paradigm, that has been essentially turned on its head. And I think much of the discussion today and over the last couple of days has been really talking about what this means. And really, digitization is really the enabler that has really taken us to where we are. When you think about two-way communication, when you think about distributed resources, some with variable capability, energy storage, you think about what was mentioned about allowing the vehicles and buildings to be a part of that exchange and interaction, customers themselves. So this is essentially what we have. And I think there are tremendous possibilities and opportunities before us to improve resilience, to improve reliability, to improve even security. And as I'll talk to some of the projects that I'll speak to, certainly I think as you move to the Internet of Things, you're really broadening your attack surface. But by the same token, I think there are technologies and applications, algorithms that you can develop based on digitization that can actually help you as well. So we'll essentially walk through that. So talking about situational awareness, one of the first areas that I'll cover is this area that we call substation and system visualization. And the idea is to put your finger on the pulse of the grid. So one aspect of that is the system, one aspect of that are the components and the various assets. And so we've deployed a lot of sensors with the goal of trying to understand in real time the health and the condition of each asset that we have. And of course, we're doing that in a phased approach, so not every substation has this. But the thinking is if we can get a handle on where we are in relation to the health of various equipment, then that really positions us from a reliability standpoint and from a resilience standpoint. And so if you look at the list of sensors that we have, quite a wide variety of them, all to get a variety of phenomena brought into to bear to provide some context as to what's happening on the grid. And at the bottom, you'll see I have a reference to synchrophasors. And synchrophasors are precise grid measurements that are time-stamped. They're accurate to 1 microsecond. They've got GPS input, and that allows you to move across from simply local phenomena to really being able to look across the entire interconnection. PMUs were developed around 1989 at Virginia Tech. So they've been in the industry for a while, but it was the August 14, 2003 blackout that really put a jolt and jerk in terms of the proliferation of PMUs, where some of the findings were a lack of wide area situational awareness, a lack of the ability to manage the grid in terms of its dynamics. And so if you compare it, for example, to SCADA, a SCADA has a 6-second scan rate. So every 6 seconds, going out and looking at your RTUs at substations. Synchrophasors allow you to do that 30 times per second. And by the way, not just magnitudes, but the phase angles. So there are tremendous opportunities in terms of overall situational awareness, the ability to detect misoperations, the ability to leverage from event analysis perspective what's happening. And all of this with the goal of increasing reliability, resilience, and overall efficiency. Another area, and you've heard about it, we just talked about the number of sensors, and as you begin to add sensors, the data that you need to begin to manage and leverage is really growing exponentially. And so now, how do you then take that data and apply it to bring business value? And so this particular effort is a means to do that. The architecture you see on the left is really looking at how do you incorporate this wide array of different data sets and data sources, some of them like the energy management system, if you've got sensors on your transmission lines, sensors in substations, phasor measurement units that I just alluded to, other sensors and other data sources. How do you build an infrastructure that is scalable and extensible? So what you don't see here are the sensors that will be developed tomorrow. A lot of different data type coming with protocols that we may have today, or might not have as yet. How do you ensure that you can develop an infrastructure which ingests all of that to facilitate analytics for a variety of stakeholders that I've got segment over in the visualization areas? So you can think about this infrastructure being used by different functions across a utility. We're siloed kind of like everybody else, and one of the things that we've seen is folks tend to develop their own databases for projects they're working on within their function. This particular effort is an attempt to kind of move away from that. So looking at how you can provide different function information, and also all the different operating companies that I alluded to earlier, how can we move across that? So this is essentially a large infrastructure trying to leverage data for decision support. At the bottom, you see one of the things that we're attempting to do is not only coalesce and kind of bring together the data itself, but the different applications. Sometimes you have an event and you've got operators that have to look across a variety of screens to try to piece together what happened. And so if you think about it, let's suppose about 20 minutes ago an event happened on the grid. Can you have a portal which will allow you, for example, in terms of time, to query across all the relevant databases? So PMUs, SCADA, if you've got a lightning feed, if you've got distribution, if you've got power quality, how can you make that easier such that after something happens, you're able to take that and easily quantify what's going on? And along with all of that data, it's important to, before you have meaningful analytics, to really assess the idea of data quality. The old adage, garbage in, garbage out. And one of the things that's very, very important to do with ubiquitous data sources is to really have an effective mechanism to manage around that. In the middle, there's that component that I alluded to at the beginning. How can you understand the status and the health of each component across your grid, and actually then move from just the historical now to the predictive? Can you detect incipient failures in your equipment? Can you detect that you're about to have some kind of grid disturbance? How can you begin to leverage that data? And then to the right, you look at the various types of users we see leveraging a platform like this, different analytics users. You've got farmers where their process is pretty well defined, change the input, the output changes, and they go on with their day. Miners taps in a little bit more in terms of correlation and analytics. But the piece that's really interesting to me is really the explorers, because I believe with all the data that we're generating, there is a lot about the grid that we don't know, that we don't understand. And I think this is the perfect mechanism, or opportunity rather, to really begin to apply artificial intelligence, deep learning, and really try to understand the things that we don't know. Some years ago, I was a part of an effort along the lines of multivariable statistical analysis, and the goal was really to try to look at volumes, large volumes of data, and identify patterns and correlations that from a human perspective you would never have imagined. And what that allows us to do is really change our thinking around the best ways to operate the grid and to really navigate and mitigate out of different scenarios. I think it's easy to appreciate the importance of cybersecurity. I think that one kind of goes without saying. The interesting thing about this particular project is normally when people think about cybersecurity, there's the externals, or if you build your walls high enough and you make it a fortress, nobody will get in. I think we have seen over time that is just a matter of time that somebody actually gets in. And so the question is, what do you do after that scenario? How do you manage your system such that you don't have to have a total collapse? How do you manage through that? Interestingly, with this, we have modeled the electrical grid, as you can imagine, the control systems, the communication systems, and we still have intrusion detection and prevention. What we assume in this particular project is that somebody, a bad actor, has found his or her way into the control center. So there's a command going to the substation to open or close a breaker. So through modeling and then real-time analysis, we actually look at if the command is coming out to open a breaker, we do what we call faster than real-time analysis and say, what would happen if this breaker were opened? So you've got detailed modeling, and then you have an equivalent for the rest of the network, and you run that what-if scenario based on this actual real-time condition with all the grid currents and voltages and the like. What would happen if I were to open? And if you're going to have devastating consequences, you can actually block that command. So this is, again, an example of what I alluded to before, that certainly you increase your attack surface, but again, you can still use digitization to help you from a sophisticated standpoint of kind of managing through some of these threats. Customers are at the center of what we do, and this particular effort is really looking at how we can learn more about the shift in terms of how customers are interfacing with the grid, the new opportunities, the fact that they are more educated, the fact that they want to be more participatory in terms of their energy exchange and experience. So in Birmingham, Alabama, we've got a neighborhood called the Smart Neighborhood, where Southern Company partnered with, and Alabama Power in particular, partnered with a builder, and we built 62 homes, and we added a lot of efficient technologies to it. So we added the ability to interact with the grid from a building standpoint, so with very tight thermal envelopes, very, very efficient. In fact, the efficiency of the homes here are at least 30 to 40% more efficient than the ones that are built to code today. And the idea is really to push the envelope to say, if our customers begin to adopt technologies like this that allows them to have smart devices, building to grid integration, what does that look like, and how do we need to position ourselves? Because you can appreciate the challenge of dealing with a scenario like this. And by the way, I should add that this is a microgrid. If you look to the top right-hand corner, you'll see the solar resource that connects to the grid or the neighborhood on the left. There's diesel, there's energy storage, and so you can actually support this in islanding conform. So when you think about, if you move from 62 homes and one neighborhood to having this all across our service territory, what does this begin to look like? And a part of what we try to do in research is really extend ourselves and begin to try to answer tomorrow's questions today to make sure that we're prepared. And the final project or initiative I'll talk about is this Grid Visualization and Analytics Center. Everybody here on the panel, and including myself, we've really talked about a lot of the challenges and opportunities associated with digitization. And one of the things that we're trying to do is to position ourselves to be able to deal with those challenges and address them before they hit us head on. So this is an environment within the utility that's built to leverage real-time data to do research and analysis. So this looks like a control center, but we don't have controls outside going back to the grid, but we actually have real data, the synchrophasers, EMS, distribution. We're being set up to do that, where you can take an application and use actual data with all the challenges, latency issues, dropouts and the like, and look at how you need to develop the resiliency in the application to improve grid resiliency overall. And so this is a test bed for next generation control centers. One of the things we like about it is the ability to stand up applications and technologies very rapidly. In the utility world, we don't exactly move at the speed of light, so sometimes you can be in a discussion about a project, and by the time you determine where you're going to site it, who are going to, the folks that are going to participate and the like, you're kind of 6 months down the road. This kind of allows us to bridge the gap in terms of speed, and so bring a lot of things to bear, looking at visualization approaches, not for its own sake, but really to say, if you've got tabular displays? Are there better ways, more intuitive ways to take data, all of this data that's coming in, and provide folks that are really wanting to understand what does the data mean? And so improve decision support and the like. So here we have an opportunity, I think, to deal with a lot of opportunities, a lot of issues, and I think there are a lot of different areas that we have synergy that we can certainly work together to make improvements. Thank you.
Thanks, Clifton. So we have time for questions, and I'd like you to start thinking about your questions. While you're thinking about them, I'd like to start with the panel to talk about some of the things that you brought up. And Antonio, one of the things that you mentioned that I think I wanted to sort of bring out and have the panel sort of discuss is interoperability and standards. I think in all of our minds, this topic, when we digitize data, we immediately assume it's available for management or security or integration. In my experience, this is not often the case. My world is mostly health outcomes, and so just take standards in health and digitized health or electronic medical records. This is a very difficult and challenging area to make all the data that is digitized available. And we hear about advances like blockchain or other ways to help standardize data, but I'd really like for each of you to give us a real sense of how interoperable is this digitized data? What domain size are we going to be able to control? I mean, I think in our minds we think about cities that might be managed and have a grid that's digitized. You mentioned customers over many states. What is the interoperability and standards around this data right now from each of your perspectives? Juan, you mentioned a home with a variety of devices, each generating data probably in its own format. So let's bring that out and put a little more light onto that particular topic. Who wants to go first? Maybe Juan, I'd ask you to go first.
Okay. So interoperability and standards it's one of these things that's it's necessary, not always the most exciting area, but what we've found over time is that it's so critical, it's so important. Data formats and protocols for how data is exchanged are essential just for operating. We're also finding in our understanding as we're trying to design this this future infrastructure or set a trajectory on what the system might look like in the future, our models are not always interoperable. So we need to look at it from that perspective as well, from the more fundamental level. So we've got some work going on right now to try to do that in development of a co-simulation framework. We have one going on that's being developed under the Department of Energy with several labs called Helix. And it allows us to share information across these different models. It allows us to tie hardware in the loop and start to explore where there might be some issues that maybe aren't always obvious. Seeing a standard written down does not necessarily tell you how it's actually going to work. So it's really important. I think you bring a huge point there. Standards are critical, not always the sexiest thing, but it's important for the stakeholders to get involved to find what are the standards that make the most sense. I have been involved in standards bodies, and you find that you want standards that are going to provide for the good of the stakeholders, not just for the good of one particular organization or technology. So it's important to have input from a variety of stakeholders as you do develop those interoperability standards.
Antonio?
So for Eaton, for many, many years, used to be a way for us to make more business. We thought that having a close interoperability, a close connectivity was the right thing to do. And, we had many customers asking, hey, we love your voltage regulator. We love your distribution transformers, but we would like to use our own controller. We would like to use our own relay. And we say no. For many years, we say no. And that was a mistake. And that was a mistake that we corrected probably 5 years ago or so. And a good example was our medium voltage regulator. We had customers asking, okay, we would like to use Schweitzer relay, which works pretty well with other voltage regulator manufacturers. And somebody at the business, a new person, obviously, came in from outside with a different perspective, say, well, there is an additional opportunity to make business if we open our protocols. And so we started doing that, and we proved that, yes, that's true. We are a leader in medium voltage regulators. We can be stronger if actually we open our protocols and we open our controls to accept somebody else. And that has been the case since then, and we are committed to continue that strategy because we believe it's the right thing, not only for our own business, but it's the right thing for our stakeholders and our customers. Yeah.
Clifton?
Both responses certainly resonate with me from a utility vantage point because from a utility, we have been some of the customers that have reached out to different vendor suppliers that we don't have interoperability. And so I think kind of trying to leverage the utility voice, not just as a single company, but really kind of speaking as a utility and being a part of collaboratives that allow us to speak with one voice. I think vendors are beginning to hear that message, and certainly I think that's echoed by what's mentioned here. The other thing is, though, after you have those conformity standards and different protocols, you actually have to do some testing. And so we actually have some test bed where we're doing some digital substation work, where we actually are taking merging units and the like, looking at protocols and standard approaches like IEC 61850 and others. And so the idea is, even though some things are prescribed, I think it's important to look and try to understand what that means in terms of the business, because some of these approaches promises a lot of value, and trying to understand how that needs to be extracted. And it's kind of difficult to say that without quickly acknowledging that I think there's a comprehensive ecosystem which is at play. So as I begin to talk about that particular protocol or standard, then now you need to look at how the personnel that you have needs to be educated and be brought to the place where they now understand how to deal with the changes. So you want interoperability, and you need to get your personnel to the place where they now begin to understand it. So there's testing, there's education, and I think they're speaking to the vendors from an engagement standpoint.
Great. I'm looking to the audience to see if there's a question. I think there's a couple up front here.
I'm Frances Consilia. I'm a commissioner with the Colorado Public Utilities Commission, and my colleague John Gavin is sitting next to me. My question is for Dr. Black. One of the things we are very concerned about at the Colorado PUC is customer data confidentiality. And what assurances do your regulators require you to give that the data is confidential and that the utility or a third party is not going to be turning into another Facebook, scraping the data off to upsell people?
So, one of the interesting things for me is, and maybe this may sound funny, I work at a utility, obviously, but I'm also a consumer, I'm also a customer, and so I wear both hats simultaneously. So I don't look at it that the customer has this concern separate from the utility. At the utility, we have that concern. And so when we enter into projects or different mechanisms where customer data is in play, it's something that's absolutely critical and important to us. We have had instances where we have turned down requests based on that kind of sensitivity. And so when we do enter into different agreements, we try to make sure that we do everything that's necessary, whether that begins with anonymizing the data, scrubbing the data, making sure that we have the data sharing agreements in place. But that's something that we take very, very seriously, and I don't think we have to look very far to see where there have been significant issues where all the safeguards have not been in place. So my short answer is really that's something that we take very seriously, and we try to adhere to strict standards to manage that confidentiality and privacy.
Thanks for that question. I'd like to ask another question while we're waiting for the mic to come back up again. And you bring out, the question really brought out sort of privacy and the human side of digitization and some of the effects. I'd like to maybe build on that a little bit, because we know human factors can really influence energy utility, energy utilization, I mean, and so here we are digitizing. How do we include human factors in the analytics of the digitization of energy? And how are you thinking about that? I mean, this is a question you can certainly turn to analytics in general, but given that we know human factors are big at play here, humans aren't easy to digitize.
So I'll follow up on that, because we're dealing with that right now, and I'll approach it from an angle that hopefully you'll appreciate. We actually have our labor force changing. We have folks that have been at the utility for long periods of time. They're retiring, and so not only do you have younger folks at the generation, at the utility, but you also have a shifting in how workers think today, where people would be staying in one functional area for 30 years. Now people tend to like the idea of moving around. And so to come back to your question, one of the things I think it's important is to develop these analytical capabilities to help to improve decision support. So both for the purposes that I mentioned it, but also from the angle you came from, which is to say, can we develop robust systems that try to help to manage against this lack of experience, all right? And so obviously you'll still need expertise, and there's never going to be kind of anything that you can replace that with. But I also think that we can kind of leverage learnings, we can leverage trends and patterns, and we can build robust systems to help to manage that deficiency and deal with this particular issue.
Anyone else want to?
Yeah, at Eaton, we have a program, actually a project, where we are working with a healthcare provider exactly to understand the human aspect of, let's say, a home. And we're looking into, gear up the home with sensors and trying to understand if there is any kind of changes in behavior in case somebody is having a problem, a health issue. Maybe the way we are using water, the way we are using energy in different ways, the way we're using the air conditioning, the way we're using our fridge. There may be some patterns that we can probably identify, and at this point it's just a hypothesis. We may be wrong, but we're doing the research to see if there is any ways we can identify potential issues going on that are related to someone's health in the house. So that's definitely an important aspect that we are researching.
So I think that's a huge area of potential research. We haven't figured out on the cyber side, I mentioned earlier, how to defend against the insider. So there's a lot of opportunity there. There's also interesting, as we were engaging the consumer more and more in operation and reliability of the energy infrastructure, what we're seeing is how can an adversary potentially take advantage of social behavior? And the fact these trends, we don't even know exactly how people are going to start to engage as they have more and more control, from at their fingertips in how they engage in the energy infrastructure. There's a paper that I just saw. Just came out recently from a university in Singapore, where they're looking at vulnerabilities potentially that could be exploited in that area. And it's really interesting where they would essentially take advantage of certain social behaviors, or community behaviors, and how they're using energy, and use that to their advantage to cause a certain kind of effect in operation of the power grid. So there's a lot of opportunity there for us to have a better understanding in how we can make it a more constructive, which I think is what Clifton's trying to do there, and also to make sure that we design in a way such that we don't expose additional vulnerability.
Great. I think we had a question up here. Oh, over here. Yeah.
Okay. Yeah. Frans Westenbrink from Woodward. A lot of similar things as Eaton, but smaller company. Aerospace and industrial, and we do controls. The question is for Clifton, but the others can respond too. In the IoT analysis that you gave there, you said, here's all the sensors that we want to have, both in the homes, in the substations, but looking at how much power, how much customers you have, the amount of data coming out of that must be massive, like terabytes per hour or so that you upload. So from experience in discussions on IoT, you probably have in your company similar people on different sides of the spectrum, probably younger people that say, give us all the data in the cloud. We put learning machines, artificial intelligence on it. We will come back with stuff you never dreamed of, but that will cut your costs by 50% as a utility. On the other side, you have your 30-year-old engineers that have worked on substations forever. They know them in and out, and they say, here's the Pareto of what goes wrong on the substation. We know exactly what it is. Just give us a couple of sensors that predict the stuff from happening, and we give you, at a fraction of the cost, 80% of the reduction. So that must be, I bet, a familiar discussion. So what is your approach on that? How are you guys approaching that from prioritization to keep relative spread of investments versus the benefits that you want to see?
So great question, by the way, and sounds like a sidebar in some discussions that we have at the utility, just exactly what you described, where somebody would like to unleash the power of analytics, and they say, well, we can increase our ability to train the algorithm if you give us all the data. Certainly there are risks and things associated with that. So a few things I would say. One is when the word cloud appeared some time ago in utility discussions, there was significant pushback. And while there are concerns and legitimate concerns, there is an evolving posture. And I say that because there's analysis being done to look at the varying sensitivity of different types of data, all right? And so some data is more sensitive than others, and making the delineation among them, I think, is important, so you can kind of determine. The other thing that you can do is think through the notion of not just the public cloud, of private cloud, and so that's an attempt to kind of keep kind of closer to the vest and then still leverage some of those capabilities. But it's not, there's no silver bullet. It's really a discussion. It's along the continuum, but it's one that we are approaching. You're certainly right. The volumes of data that we have are massive amounts to deal with. And one of the projects I talked about looks at an infrastructure to kind of do it. But I think the idea of being very strategic and sensible is extremely important. So for example, if you've got tons of data and you're going to perform analytics, even in the architecture I described, you don't have to move everything from its native store to someplace else. Maybe you need to use publish and subscribe. And so just being very strategic with understanding your architecture, understanding the varying sensitivities of the data types, and sometimes maybe you need a hybrid solution. So all of those things are really on the table, and it's an ongoing discussion to solve the problem that you raised.
That was perfect, because we're just pretty much out of time. We're ready for the break. Before we break, I just want to say that this topic is really evolutionary and revolutionary. I mean, we're going to see this topic at every one of these symposiums in the future. It's going to be presented in different ways. Here we're talking just about getting the data into the format and understanding the challenges of doing that, managing, securing it, dealing with privacy issues. We're in this game, and so I can imagine in years to come we're going to have really interesting dialogues about experiences with doing this at various components of the energy grid, leading up to managing something that really protects us from large types of catastrophes and resiliency, where we'll see this at various domain size. So thanks for coming on the journey with us this morning, and look forward to seeing you in future discussions around this topic. Thank you.